Assalamu alaikum. Hello everyone and welcome back to another session of Analysis 2. Today we are going to talk about indefinite integrals and antiderivatives or primitives. Note that the rules of derivatives play a crucial role to understand this course. Now let's get started. First, let's take an example to understand what is an antiderivative that is also known as primitive. For instance, if we have the function f of x equals 2x, then its antiderivative, noted capital of f, equals x squared. You have to know that to verify that the antiderivative is correct, we simply use the derivative here. The differentiation of x squared equals 2x, that is lowercase of f. Another example to take in mind is, for example, the primitive of f prime of x is f of x, or the primitive of the second derivative of f is the first derivative of f. Here, we have to know that if we take the same example, this function has many primitives. For example, x squared plus 1, x squared minus 2, x squared plus pi, etc. With this idea, we can learn what is an indefinite integral. The indefinite integral of f is all possible antiderivatives. Here, c is constant that is eliminated if we use the differentiation. If we take the previous example, the indefinite integral of 2x is x squared plus c. Now, let's review together some basic rules of integration. First, the power rule. For n different from minus 1, the indefinite integral of x power of n is x power of n plus 1 over n plus 1 plus c. Another way to make this rule is the indefinite integrals of u prime multiplied by u power of n. Here, u is a function. We use the same rule, but be aware, if we don't have u prime multiplied by u power of n, then we can't use the power rule. Let's take an example. Let's take two functions, x squared plus 1 power of 2 multiplied by x. Here, to make an antiderivative of these functions, let's remark the second function. Here we have function, let's note it u squared, u prime equals 2x. Then we multiply by 2 and divide by 2 to have u prime multiplied by 2 over 2. Here we can use the power rule and find the antiderivatives that we can write on the form power of 3 over 3 and multiply by 1/2 plus c. We can write it also on the form the function power of 3 over 6 plus c. The first example, we can't use the power rule directly, then we develop it. Sorry, we have x power of 4 to x squared plus 1. Then we can write the antiderivatives on the form x power of 5 over 5 plus 2x cubed over 3 plus x plus c. Now let's take another rule, the exponential function rule. The antiderivative of exponential of x is the exponential of x. Here we add c to have all possible antiderivatives, and the primitive of exponential of u multiplied by u prime is the exponential of u. Here u is a function. To understand the limitation of these rules, let's take the two examples, exponential of x squared and the exponential of x squared multiplied by x. The a0 function is the second one because the derivative of x squared equals to x, then we multiply by 2 and divide by 2 to have u prime multiplied by the exponential of u, and we can use directly this rule to obtain the antiderivative exponential of x squared over 2. But the first example is very difficult. Sorry, but I also don't know the primitive of exponential of x squared because we can't use the rule of elementary function. In your future, you can learn some numerical methods to evaluate integrals or primitives involving this kind of function. Now, let's see another rule, which is the reciprocal function rule. The indefinite integral of 1 over x is the logarithm of the absolute value of x, and the integrals of u prime over u is the logarithm of the absolute value of u plus c. Here we use the absolute value because we can't calculate the logarithm of negative numbers. For example, the integral of exponential of minus x over exponential of minus x plus 1. To calculate it, first we remark that the derivative of the function written below is minus exponential of minus x. Then we have to multiply by minus 1 two times to use the rule. Then the result of the indefinite integral is the logarithm of exponential minus x plus 1 plus c. Here we can eliminate the absolute value symbol because exponential of minus x is positive and 1 is positive, then we can write the function without the absolute value symbol. That is a note for today. In the next video, we are going to see other rules like the primitives of trigonometric functions or hyperbolic functions or inverse functions. Thank you for watching and see you soon.